Good morning. Chapter 12, Lesson 4 is page 555, and we're going to be using quadratic functions. Let's start off with number 1. We're going to be talking about parabolas. We have vertexes and axes of symmetry, and we have functions that look like ax squared plus bx plus c. But for number 1, it just says, you know what, let's just find the function, graph the function, and let's find the domain and the range. So just as a few remembers, we have the domain, and that's the same as the x, and the range is the same as the y. Okay, so we're going to just make our t-chart here and see what we can come up with. And we're going to have some x's and we're going to have some y's. Oh, and I forgot. The function f of x, we could actually, I'm going to do it here real time, we could actually erase that function and replace that with a y. So that's what we're going to do. We have y is equal to negative 3 times x squared. So my favorite point, again, obviously, is x is 0, and if x is 0, y is 1. Y is 0, sorry. And if x is 1 and x is 2, if x is 1, we end up with negative 3. And if x is 2, we end up with negative 12, because 2 squared is 4 times negative 3. Interesting thing, if we stick a negative 1 in here, negative 1 squared for x is still 1 times 3 times a negative 3 is a negative 3. And if we stick a negative 2 in there, we end up with 4 times a negative 3, which still gives us a negative 12, because you remember when we square a negative number, it turns positive. So we can tell that the domain is going to be all the x values. And the domain is going to be, it looks like, numbers that are 0, 1, 2, negative 1, negative 2. And so the domain is going to be, it turns out, and they go on and on and on, all the x's are all real numbers. And the range turns out like it's going to be 0, negative 3, negative 12, and all kind of numbers like that. But if you look at it, the range is going to be all numbers that are less, x has to be less than or equal to 0. So that's the domain, and that's the range. So let's make a graph, and we'll start off with 0, 0. I'm not sure how good this is going to work, but let's give it a shot. 0, 0, 1, negative 3, negative 1, 3. We're going to go with 2, negative 12, negative 2, 12. And you're going to see that our parabola, and I'm not sure how successful I'm going to be. Remember, we're not connecting the dots. Looks something like that. Kind of a lousy job. And you realize that the parabola continues forever in the negative y direction. That's why I'm saying, oops, I made a mistake here. That the y's have to be less than or equal to 0. And if you spread out the domain and you followed this parabola, it would go on forever. So the domain would be all real numbers, both negative and positive. And the range would be, excuse me, all real numbers as long as they're less than or equal to 0. Pretty simple on that one. Let's jump on to number 29. And number 29 says, here's a picture on page 555, and I'm not going to try to draw the picture. And it says, look at the picture and see for number 29, how many seconds after launch is the projectile 128 feet above the ground? Well, they also gave us the formula, d is equal to 96t minus 16t squared. So I'm going to not use the picture, and I'm just going to try to come up with an exact solution. And I'll explain to you when we get the answer what the answers mean. So let's get started. So we have 128 turns out to be 96t minus 16t squared, or minus 16t squared plus 96t minus 128 turns out to be equal to 0. I love to factor, and I love to use that zero product property. And as I'm taking a look at this, it dawns on me that I could factor out a negative 16, leaving me with a t squared minus 6t plus 8. I just factored out a negative 16. Well, I know the zero product property tells me that 0 is not equal to negative 16. So this answer I have to discount. So that leaves me with t squared minus 6t plus 8 has to be 0. And I remember that the factors for that were t minus 4 and t minus 2. And my zero product property tells me that I set those factors to 0. Minus 4 and minus 2 will give me the positive 8, and then when I add them together, minus 4t and minus 2t, I get minus 6t. Well, that tells me that t minus 4 must be 0, and t minus 2 must be 0. Well, if I solve for t turns out to be 4 seconds, and t turns out to be 2 seconds. And so there are two answers. So let me go back to the problem that's in the book, and I'm going to not do a very good job, but I'm going to try to draw it really quickly. And my parabola looks like it goes up and it comes down. And what they're telling me in the parabola is this is the height, the distance, and this is the time. So it's a plot of distance versus time. And at 128 feet, here's 128 feet, let's pretend, I have two answers for the time. As the projectile is launched upward, I hit this point. That's at time 2. And then it goes up and it comes down, and it comes down at 4 seconds. So there are actually 2 points in the parabola when the projectile, whatever it is, reaches 128 feet on the way up and on the way down. That's it for today. We'll see you all tomorrow.